So now we're going to continue with logarithms and look at some logarithmic equations. So a logarithmic equation would be the likes of what you see here, where you have your logs and you have some unknown variable, in this case it's x, and you also have your equals to sign, and we have to solve these equations for x. So if you're really familiar with the rules, solving logarithmic equations is fairly straightforward. So this video, remember, is a continuation from the introduction to logs video. So it's very important you're familiar with all of the rules that we looked at in the introduction to logs video before looking at the logarithmic equation. So I'll go through question 5 here to begin with. Log to the base 3 of 2x plus 5 equals 2. So log to the base 3 of 2x plus 5 equals 2. Now this is a fairly straightforward logarithmic equation. What we're going to do is we're going to get rid of logs and turn this into an algebraic equation. So that's the idea. You want to turn the logarithmic equation into a straightforward algebraic equation. And we're going to use this rule here that we looked at in the previous video, how to go from log format to index format. So remember, a to the power of x equals y. A to the power of x equals y. So applying that rule on what I have here to get rid of logs, I can simply say 3 to the power of 2 equals 2x plus 5. 3 to the power of 2 equals 2x plus 5. So 3 squared, we know that that's 9. So 9 equals 2x plus 5. So then solving this is fairly straightforward. 9 minus 5 equals 2x. 4 equals 2x. So therefore we know that 2 is equals to x. So that's a fairly straightforward question. Now, the thing you have to remember is you cannot get the log of a negative value, okay? So when we have our x equals 2 here, we have to realize, we just have to check, is that a possible solution? So we look back at our question, and if you fill a 2 in for x there, what will you have? So I'm just going to do that here. So I'm just checking. I've got log to the base 3 of 2 times 2 plus 5. So that's log to the base 3 of 9. So it's okay, and we know that that does equal 2, so we know our answer in this case is correct. So the whole reason for this check was to make sure that we weren't trying to get the log of a negative. Sometimes with logarithmic equations, you can do everything correctly and still end up with a solution that we have to cancel. Let's have a look at another example. So the next one I'm going to do for you guys is this question 7 here. Log to the base 2 of x plus log to the base 2 of x plus 2 equals 3. So log to the base 2 of x plus log to the base 2 of x plus 2 equals 3. So like the last question, remember my goal in the last question was simply to turn it from a logarithmic equation to an algebraic equation using this rule that we have right here. So in order to get rid of logs, we're generally using that rule. Most often we're using that rule. So I want to get to that point where I can use that same rule that we're talking about. Now, in order to use this rule, we only have to have log appearing once on the left-hand side. Right now, I've got log plus another log. So I have to handle that first. And we know what rule we can use to handle that. We've seen this before. If you have 2 separate logs, log to the base a of x plus log to the base a of y, and you add them, you get log to the base a of xy. So that's telling us you multiply the arguments. So I'm going to use that rule right now in order to help me continue with this particular question. So I am going to add these 2 terms using that rule, calling this log to the base 2 of x times x plus 2, and that is all inside in the log, and that is equals to 3. In other words, log to the base 2 of x squared plus 2x is equals to 3. So now I'm at the situation where I've got log just written once on the left-hand side, so I can finally use this rule that I have here to get rid of my logs. So in this case, using that rule, this will be 2 to the power of 3 equals x squared plus 2x. In other words, 8 is equals to x squared plus 2x. So we can see that we have turned it from a logarithmic equation into an algebraic equation. This particular algebraic equation is a quadratic equation. So I've got x squared plus 2x minus 8 is equals to 0. So I'm just going to bring that over here. X squared plus 2x minus 8 is equal to 0. Let's solve this quadratic. X plus 4 x minus 2 is equals to 0. So you get x is equals to minus 4 or x is equals to 2 are my two solutions in this case. Now, like the previous example, I have to check that those solutions will not result in me getting the log of a negative. So when I look back at the question here, I had log to the base 2 of x plus log to the base 2 of x plus 2 is equals to 3. So bringing that with me, log to the base 2 of x plus log to the base 2 of x plus 2 is equals to 3. And one of my solutions was x equals to minus 4. So if I use that solution, x is equals to minus 4, and sub it into the original question, I will have log to the base 2 of minus 4 plus log to the base 2 of minus 4 plus 2 is equals to 3. So I can see here, I'm getting the log of a negative. You have to remember, you cannot get the log of a negative. That thing right there, is not allowed, all right? It's just impossible to deal with, the log of a negative. So that means x equals minus 4 has to be disallowed. So this solution here has to be disallowed. And what about the other solution, x equals 2? Well, if you fill that solution in, you can see yourself you're going to get log to the base 2 of 2 plus log to the base 2 of 2 plus 2 is equals to 3. And that is okay. Nowhere along here do I end up getting the log of a negative. So even though I made no mistakes, I did everything as I should. I used my log rules. I turned it from a logarithmic equation to an algebraic equation, and I solved that algebraic equation. I got two solutions. So I did everything correctly, but the point is you have to check your solutions because you cannot get the log of a negative. If either of your solutions results in you getting the log of a negative, then you have to disallow it like I did here. So in fact, in this particular case, x equals 2 is the only solution of the equation. Okay, one more example for you. This one, I'll do question 9 for you here. 2 log to the base 5 of x minus log to the base 5 of x minus 1 equals log to the base 5 of 4. So once again, I have it written here. Our first goal is to reduce the number of times we see the word log written. So I have a minus sign here. So I will eventually be using this rule here, where when you're subtracting two separate logs, you divide their arguments, you divide what's inside them. But I cannot use this rule yet because I have a 2. If you look here, I have a 2 in front of the log. If you have a number in front of either of the logs, you cannot use this rule. We got to deal with that number first. So we have a different rule that we looked at in the previous video that tells us if you have a number in front of a log, q log to the base a of x, that number can come up as a power of the argument of the log. So the q can come up as a power of x. All right, so we've used that. We've seen that rule in the previous video. So I'm going to use that rule to continue on with this equation. So my next line on this equation will be, I'm going to use this rule here on the 2 and rewrite this line as log to the base 5 of x squared. Now it's just the x that's squared, not the whole log. It's just the x that's squared. And the rest of it will remain the same. Log to the base 5 of x minus 1 equals log to the base 5 of 4. So now that I've dealt with this number in front of the log, now I can go ahead and use this rule here, which tells me if I'm subtracting two separate logs, I divide their arguments, I divide what's inside them. And that's exactly what I'm going to do here. I have two separate logs, and I'm going to use this rule to condense it and represent it as one log. So my next line here, log to the base 5 of x squared divided by x minus 1 is equals to log to the base 5 of 4. So we're in a good position here. Now this is slightly different to the previous two examples. In the previous two examples, when I did my work on the log rules, I had log equals a number. You see that there? I had log equals a number. And same in the first example, I had log equals a number. Okay, now when you have log equals a number, that's when you can use this rule here to go from log form to index form to turn it from a logarithmic equation into an algebraic equation. So that particular rule doesn't really apply in this situation. So if you see the situation I have here, I don't have log equals a number, I've got log equals log. So that's not a big deal. We can just use the idea of a balancing equation to continue this. All right, remember an equals to sign in an equation means what's on the left hand side is exactly the same as what's on the right hand side. So this side and this side are the same. That's what this equals to sign means. Now we know we know that log to the base 5 and log to the base 5 mean the same thing. So if log to the base 5 and log to the base 5 mean the same thing, and these both sides are equals to each other, well then it must be the case that x squared over x minus 1 equals 4. So some people like to look at it as they're cancelling the logs. I don't like to say I'm cancelling the logs. I'm just using the fact that there's a balance here. The left and the right are the same. That's what an equation means. The left side equals the right side. So if I have a log 5, I know log 5 means the same thing as log 5. So in order for both of these sides to be equal to each other, x squared over x minus 1 must be the same thing as 4. So now I've turned it into a straightforward algebraic equation. So my next step is just to multiply both sides by x minus 1. So in doing that, I'm going to basically simply have x squared equals 4 times x minus 1. Multiplying that out, x squared equals 4x minus 4. And you can see the quadratic equation that's forming here. So continuing with this quadratic equation, x squared equals 4x minus 4. That would be x squared minus 4x plus 4 equals 0. Let's solve that equation. X minus 2 equals 0. So you end up getting x is equals to 2, x is equals to 2. So we get kind of the same answer twice, a repeated root. Now that is our solution, but once again, we just have to go back and have a look at the question. So the question, you remember, was 2 log to the base 5 of x minus log to the base 5 of x minus 1 equals log to the base 5 of 4. And we got the solution, x is equals to 2. So we have to fill that solution into the equation at the start to make sure we're not getting the log of a negative. So looking at this right here, you'd have 2 log to the base 5 of 2 minus log to the base 5 of 2 minus 1 equals log to the base 5 of 4. So you can see in this case that there is no log of a negative. So that means x equals 2 is a viable solution. So that is our introduction to log equations. Once again, the best thing for you guys to do is have a look and practice these questions. Check your solutions online. And for access to questions, solutions, graded quizzes, and more, visit www.livingmaths.com.